Assalamu alaikum students. We will continue with exercise 7.3 and today we will do question number 4 and question number 5 from it. Question number 4 states BE and CF are two equal altitudes of a triangle ABC. Using RHS congruence rule, prove that triangle ABC is isosceles. So you have been given a triangle ABC. This triangle is given to you. It has two altitudes on it. One altitude is this BE and the other altitude is this one CF, and it has been mentioned that these two altitudes are equal to each other. Keep this in mind that the two altitudes are equal. That means this CF and this BE, they will be equal to each other. Now you have to use RHS congruence. So we are limited by our congruency options. We have to only and only use RHS. Now using RHS congruence, we have to prove that triangle ABC is isosceles. Now what is an isosceles triangle? A triangle that has two equal sides. Now if we have to prove that triangle is isosceles, we will prove that this side AB and this side AC, they are equal to each other. If we are able to prove it, then the triangle will be called as an isosceles triangle. Now the condition is that you have to only use RHS congruence. So let's see how I have done that. I have given that in given I have written BE and CF are two equal altitudes. Next thing, in triangles BEC and CFB, where are the triangles? I have drawn them separately over here. I have given two triangles. One is called as BEC and the other triangle is this one, BFC. These are the two triangles which I have mentioned in here. In triangles BEC and CFB, in these two triangles, what is there? First thing, angle BEC equals to angle CFB, both 90-degree altitudes. We know that these angles, let me draw this angle over here, angle F, and this angle over here, angle E, both are 90 degrees. And why are both 90 degrees? Because we have drawn them as altitudes. We have drawn BE as a 90 degree or as an altitude. We have drawn CF as a 90 degree or an altitude. If they are altitudes, then the angle drawn by them will be equal to 90 degree. And this is the reason this angle F and this angle E, they are 90 degree. I have written them in their full name over here as angle BEC, which simply means this angle E, and CFB, which simply means this angle F over here. I have mentioned that both of them are equal to 90 degree. That is, they are equal to each other. So BEC equals to CFB equals to 90 degree. Next thing, if you look at side BC, this side BC, you will find that this is such a side which is found in both the triangles. That is, it is found in this triangle BEC as well as in this triangle BFC. This is a side which is found in both the triangles. What is such a side called? Yes, such a side is called as a common. That means side BC is a common side. So I wrote down BC is equal to CB. Why CB, why not BC? I have to just follow the correspondence. It is just because of correspondence. Otherwise, BC or CB, it means the same side, which is this side BC common. Next thing I have written is BE is equal to CF. Let's see, where is BE? This is BE altitude and this is also CF, the altitude, and I have written down that they are equal. Why are they equal? Because it is mentioned in here that these two altitudes are equal to each other. So I have written down that the altitudes are equal, that is BE is equal to CF common. uh, it is rather, it's incorrect here, it should be given. It is not common, it is given in here. So that means the two triangles are congruent by which condition? You can see that we have 90 degree, we have the side BC, which is actually the side opposite to the 90 degree, which is actually the hypotenuse, because the side opposite to 90 degree is the hypotenuse. So right angle is equal, this right angle, they are equal, the hypotenuse is equal, and one of the sides, base and perpendicular, one of the sides is also equal. So the condition is right angle, hypotenuse, and one of the sides, that is RHS condition, that is the triangles are congruent by RHS conditions, and that is what I have mentioned in here, that the triangles are congruent by RHS condition. So therefore these two triangles are congruent. Now we know that if two triangles are congruent, then all other remaining parts will also be equal to each other, CPCT. If these two triangles are congruent, then this angle, angle B, and this angle, angle C, they will be also equal to each other, CPCT. So I wrote down angle C equals to angle B, and the reason I mentioned is CPCT. So, and we know that what happens to the sides that are opposite to equal angles? If side angles are equal, then the side opposite to equal angles are also equal. Now let's move on to the actual triangle. In this triangle, this angle B and this angle C, they are equal to each other. Now tell me, what happens to this side and this side, which is opposite to these equal angles? Yes, they will be also equal, because the side opposite to equal angles is are also equal. Angle opposite to equal side opposite to equal angles are equal to each other. That means side AB, this side, and side AC, this side, they will be also equal to each other. And a triangle which has two equal sides is called as isosceles. So that means when two sides are equal, AB and AC are equal, the sides are equal, triangle is an isosceles triangle. That is what we had to prove. Now moving on to question number 5, you haven't given that ABC is an isosceles triangle with AB equals to AC. Draw AP perpendicular to BC. Show that angle B equals to angle C. Fairly simple question. You haven't given that this side AB and this side AC, they are equal to each other. That means it is an isosceles triangle. Then it said that draw this AP as the perpendicular. This AP I have to draw as perpendicular, and then I have to show that angle B and angle C, they are equal to each other. We know that they will be equal because isosceles triangle has two sides and the angles opposed to those two equal sides equal, so they will be equal, but we have to give a proof for it. So what I have written, that given AB is equal to AC, this side AB and this side AC, they are equal, it is given to us. In triangles ABP and ACP, I have chosen two triangles because when we draw the perpendicular, it divides into two triangles. First is ABP, which is this triangle ABP, and the second one is ACP, which is this one ACP, this triangle. So in these two triangles, I have written down that APB equals to APC equals to 90 degree. This angle over here, this one APB, and this angle over here APC. Since it is AP is an altitude, that means both of these angles will be 90 degree. That means this angle and this angle and this angle, they are equal to each other. So I have written down APB equals to APC, each 90. Also, it is given that AB and AC are equal because it is isosceles. It is mentioned they are equal. And this side AP, this over here, this side AP is a common side. That means in these two triangles, this triangle and this triangle, hypotenuse are equal, the right angles are equal, and one of the sides is also equal. So which condition is this? This is RHS condition. So I said that these two triangles are congruent by RHS condition. And when two triangles are congruent, what happens to their corresponding parts? They are also equal, CPCT. So if the two triangles are congruent, then angle B will be equal to angle C, and the reason will be CPCT. Hopefully you understood this. Thank you.